If you think that probability means you're reduced to guessing, the casinos of Las Vegas are ready to prove you wrong.
No more bets.
Try your hand at any one of these games of chance, and you can see the power of probability. Let's say I place a $20 bet on number 29 here at the roulette table. The house doesn't know whether I'll win on this spin,
No more bets.
the next, or the next.
1.
But it does know the probability that I'll win. In this game, it's 1 in 38.
21. 29.
So, even though I may win now and then, in the long run, the house always takes in more than it loses. The point is, the house doesn't have to know the outcome of any single card game, roll of the dice, or spin of the roulette wheel. Casinos can still be confident that over the course of thousands of spins, deals, and rolls,
No more bets.
they will win. And they can predict with exquisite accuracy exactly how often. According to quantum mechanics, the world itself is a game of chance, much like
No
this.
more bets.
All the matter in the universe is made of atoms and subatomic particles that are ruled by probability, not certainty.
At base, nature is described by an inherently probabilistic theory. And that is highly counterintuitive and something which many people would find
No more
difficulty
bets.
accepting.
One person who found it difficult was Einstein. Einstein could not believe that the fundamental nature of reality at the deepest level was determined by chance.
And this is what Einstein could not accept. Einstein said, God does not throw dice.
No more bets.
He didn't like the idea that we couldn't with certainty say this happens or that happens.
But a lot of other physicists weren't so put off by probability, because
No more bets.
the equations of quantum mechanics gave them the power to predict the behavior of groups of atoms and tiny particles with astounding precision. Before long, that power would lead to some very big inventions.
No more bets.
Lasers, transistors, the integrated circuit, the entire field of electronics.
If quantum mechanics suddenly
No
went
more
on
bets.
strike, every single machine that we have in the US almost would stop functioning.
The equations of quantum mechanics would help engineers design microscopic switches that direct the flow of tiny electrons and control virtually every one of today's computers, digital cameras, and telephones.
No more bets.
All the devices that we live on, diodes, transistors, just to form the basis of information technology, the basis of daily life in all sorts of ways. They work. And why do they work? They work because of quantum
No more
mechanics.
bets.
I'm tempted to say that without quantum mechanics, we'd be back in the dark ages. I guess more accurately, without quantum mechanics, we'd be back in the 19th century. Steam engines, telegraph signals.
Quantum mechanics is the most successful theory that we physicists have ever discovered. And yet we're still
No more
arguing
bets.
about what it means, what it tells us about the nature of reality.
In spite of all its triumphs, quantum
No more
mechanics
bets.
remains deeply mysterious. It makes all this stuff run, but we still haven't answered basic questions raised by Albert Einstein all the way back in the 1920s and 30s. Questions involving probability and measurement, the act of
No
observation.
more bets.
For Niels Bohr, measurement changes everything. He believed that before you measured or observed a particle, its characteristics were uncertain. For example, an electron
No
in
more
the
bets.
double slit experiment. Before the detector at the back pinpoints its location, it could be almost anywhere with a whole range of possibilities.
No more bets.
Until the moment you observe it. And only at that moment will the location's uncertainty disappear. According to Bohr's approach to quantum mechanics, when you measure a particle, The act of measurement forces the particle to relinquish all of the possible places it could have been and select
No more
one
bets.
definite location where you find it. The act of measurement is what forces the particle to make that choice. Niels Bohr accepted that the nature of reality was inherently fuzzy, but not Einstein. He believed in certainty, not just when something is measured or looked at, but all the time. As Einstein said, I like to think the
No
moon
more
is
bets.
there, even when I'm not looking at it.
That's what Einstein was so upset about. Do we really think the reality of the universe rests on whether or not we happen to open our eyes?
No more
That's
bets.
just bizarre.
Einstein was convinced something was missing from quantum theory, something that would describe all the detailed features of particles, like their locations, even when you were not looking at them. But at the time, few physicists shared his concern.
And Einstein just thought it was giving up on the job of the physicist. It wasn't bad physics per se, it just was totally incomplete.
That's Einstein's refrain. Quantum mechanics is not incorrect, it's insofar as it goes, but it's incomplete. It doesn't capture all of the things that can be said or predicted with certainty.
No more bets.
Despite Einstein's arguments, Niels Bohr remained unmoved. When Einstein repeated that God does not play dice, Bohr responded, "Stop telling
No more
God what
bets.
to do." But in 1935, Einstein thought he'd finally found the Achilles heel of quantum mechanics. Something so strange, so counter to all logical
more bets.
views of the universe, he thought it held the key to proving the theory was incomplete. It's called entanglement.
The most
No more
bizarre,
bets.
the most absurd, the most crazy,